Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, November 19, 2021. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you on a full moon autumn evening in Rockport, Massachusetts. These Earth and Space Reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our life-sustaining environment, and who wonder about the greater cosmos, including our place in space and moment in time. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. Today, we are joined by members of the Rockport Research Explorers, Rockport Cultural Council, Gloucester Area Astronomy Club, sundry science colleagues, far-flung friends, family, and other curious folk. Thank you for coming. This evening, I'm delighted to be hosting Dr. James Sweitzer, who comes to us from the Chicago area. James is an astrophysicist who consults on the creation and renovation of planetariums and science museums around the world. His career began at the Adler Planetarium in Chicago and continued at the University of Chicago's Center for Astrophysical Research in Antarctica, during which he made 2 trips to the South Pole. The turn of the millennium found Jim at New York's American Museum of Natural History, where he directed the creation of the Rose Center for Earth and Space. As a private consultant, he has advised scores of clients at home and abroad, most recently, China's Shanghai Astronomy Museum, where they've got the biggest planetarium ever. Jim was an early member of Al Gore's Climate Reality Project and continues to mentor young climate advocates. He currently serves on the American Astronomical Society's Committee on Light Pollution, Radio Interference, and Satellite Debris. No stranger to the classroom, Jim is taught at Columbia College in Chicago, the School of the Art Institute of Chicago, and DePaul University, where he directed NASA's space science educational programs in the Midwest. That ambitious nationwide program in space science education and public outreach is where our 2 paths crossed. This evening, James will discuss his new book, Dear Galileo, Letters from a Contemporary Astronomer to His Hero, along with other adventures in astronomy that he has been pursuing. So welcome, James. The Zoom platform is all yours.
Well, hi, Bill, and hi, everyone. So happy to be broadcasting into Massachusetts. You know, I did my thesis at Haystack. It was in Westford, Mass. So, but I know there's Boston, I know Cape Cod, and I know there's a lot of Massachusetts I really don't understand because the roads aren't straight like they are here in Illinois. But anyways, I'm really happy to do this. I'm just happy to see you again, Bill. We are birds of a feather in many ways. So I'm going to share my screen, if that's all right. So I just put out a book, okay? And it's called Dear Galileo, Letters from a Contemporary Astronomer to His Hero. So tonight I want to talk to you a little bit about why I wrote this book and why I copied you. So why I wrote to Galileo and why I'm copying you tonight. Just Bill and I were talking about this show that we're on and these things that have grown up during the period of COVID. And this too was a product of my time sequestered here. I live in Oak Park, Illinois, which is precisely on the western edge of Chicago. So I really am a West Sider, if you will. During that period, I worked on this book with my wife. We talked to you about that, but also part of what prompted it was just before the pandemic began, I received this telescope. I had ordered an early, almost jump starter edition. I didn't pay what people pay now for them, but I got an early version of, it's called an eevee scope. It's similar to the Stellina someone was just talking about. And with this little telescope in my backyard, I've been observing the whole universe during this sequestration. I've not gone much further than the backyard of the scope to a couple other places. And so, you know, I work on a lot of astronomy education projects, Bill mentioned. So I needed an outlet, and this thing became then an outlet for me. And I thought, who would be the best person to write to about telescopes? Galileo. Okay, now before you think I've gone crazy, let me explain the process. And I'll tell you a little bit about how I got into doing that. First of all, to write to Galileo, I needed a lot of help. And I want to credit, why Galileo? I'm sorry. He too faced house arrest for different reasons because of his publication problems with the Vatican and the Jesuits, but also, he was not a stranger to pandemics. There were pandemics, certainly one just before the publication, just before his house arrest, and it was not unusual for Italians to go through this, and Europeans in the early 17th century. So I felt he would be sympathetic, felt he would be interested in what I was doing, interested in what I was seeing. And then I had one other thing that helped me in actually writing the book, and it was my wife. Here she is, Kathy. She's a writer and is also a Tuscan. Okay, so she speaks the dialect, literally. And let me show you some of this, the geography. This is a little slice of Tuscany that's related to this entire story. First of all, Kathy's mother's family comes from Lucca, that city, and we go there almost every 7 years, I think. And it's just up the road from Pisa. Okay, so that's where Galileo dropped these balls off the tower, and also where he was educated. And this is all just down the road from Florence, although it doesn't say Florence on there, it does say Uffizi Gallery. And if you've been to Florence, you know that that's where that is. And Galileo, when he was next to the Uffizi Gallery, I'll show you in a minute, there's actually a museum devoted to Galileo. Maybe some of you have been there. But also, I've been a Galileo nut all my life, okay? Always chased him down. And one of the times we went to Italy, my wife's cousin drove us to Arcetri. This is where Galileo was under house arrest. This is it's called the Jewel of Galileo. Here I am with my 5-year-old son. In 1984, we arrived in Arcetri and there was nobody there. The door was locked. So what would you do? You're an American. We broke in. We went around the back and the door was ajar and we got inside. So I said, my son is maybe only going to be here once. I want him to see where Galileo lived. And of course, the caretaker came and shoot us out. So I have this background with Galileo, maybe a slight obsession. So I kind of felt I knew him. About 10 years ago, I went back. Here's a picture, at least back to Arcetri. There's the street in Arcetri where Galileo's final house was. And of course, there's Florence with the Ponte Vecchio, the old bridge taken from the Uffizi Gallery, actually. And then this time, though, I knew Franco Porcini, who was the head of the International Astronomical Union, also an astronomer based in Florence. He had a key. So we went in the front door and I got to see what it's like inside. And here I am at the balcony. It was pretty nice. If I get arrested and put into house arrest or something, I want a place like this. I'm sure the food was really good too. This is what it was like inside. This was 2007, I believe. They were getting ready for the anniversary of Galileo's invention of the telescope in 2009, and had just finished renovating. You can see it on the left, and on the right, this was Galileo's window from his study. It had bars on it, of course, this frail older man, they didn't want him to escape. But they also, the convent where his daughter was could be seen through this window. So it was really pretty. I've had a special relationship with Galileo and chasing down his haunts. So how do you write to this guy, though? I mean, really, it was an interesting challenge, if you will. First of all, he is a genius, all right? You all probably know some geniuses in your life. I don't pretend to be anywhere close. It's challenging because he's very, very smart. Also, he's so smart they've made a museum for it. Houses his collection, but a lot of other ones that belong to the Medici. It's called the Museo Galileo. It's in Florence. You can see the towers of the main square in Florence there as well. Anyway, so first of all, you're dealing with him. And I'm sure a lot of you know a lot about Galileo, maybe some of you even more than I do. Let me give you a little bit of background. First of all, if you go in the museum, it's like a reliquary. I mean, it's Italy, you know, and they have bones of his fingers in these little jars in this museum. Pretty interesting. Reminds me more of a church than it does of a regular history museum, but nevertheless he does. And it's sort of appropriate because Galileo really had his fingers all over modern science. This is another dilemma, if you will, for people writing about him. Our physics of motion that we talk about in physics classes is based a lot on what Galileo's modern notions of describing motion. He was a pioneer in trying to explain gravity and gravitation. Didn't quite get there, but he got really, really close, did some really important things. Of course, he came up with the empirical evidence to basically prove, if you will, or well establish the Copernican heliocentric system of planets going around the sun, which every grammar school child knows. Of course, he was the inventor of the astronomical telescope. And he was really, I mean, in my mind, the promoter of empirical method in science. It wasn't just about thinking about things, you had to go do experiments, observations, and so on. So more than anything, Galileo was responsible for setting the scientific revolution into motion. Okay, so all these incredible things can be traced back to him. He would have thought about a lot of the things modern physicists would think of, but his knowledge base was different. He had only a 17th century library. In the museum, they have a lot of his books. There's some of his books. We know exactly what he had. And he did not have, the physics textbooks we would have today. Certainly nothing with Newton's stuff in it. Forget Einstein and quantum physics. And yet, for a modern astrophysical view of the universe, you need to know all those things. So that was my dilemma, writing to him. And the idea in the story behind the book is I wanted to bring him up to speed on what modern astrophysics has found. So you might think it was crazy, but it was actually a lot of fun, but really challenging because I always had to try to think, I'm trying to explain it to Galileo. So the way I did it was as follows. I'm just going to give you a few things. I focused on just a few areas of overlap where I knew he would really want to be brought up to speed. Of course, gravity, one of his number one concerns. He really had to know about gravity. And so I had to get into gravity all the way, dealing with Einstein as well. So that was a long way to slog, as you'll see if you look at the book. Also, the scales of the universe, of course, changed dramatically. This is a dramatic armillary sphere in this Museo Galileo. And remember, the Museo Galileo is really the collection of the Medicis that's been put there. So it's not just astronomy, there's other sciences that are present there, but they have this thing is about 10 feet high. This is the Ptolemaic view of the universe with all these rings upon rings. Galileo, of course, got past that, but I had to take him all the way out to the expanding universe in the cosmic microwave background. So I had a lot of ground to cover there. The third thing was, I couldn't assume he thought of matter the way we do. He didn't know the periodic table, he didn't know the names of the elements we know. This is more like there's this, I pulled this picture. This is in Florence too. This is currently it's called a pharmacy there. It's a restored Baroque pharmacy. Now they dispense cosmetics basically, but this is where you would go to get pharmaceuticals in the past too. And so his notion of matter would be quite different than ours. And I had to deal with that as well. So I'm going to take you through those three basic areas. Then we're going to do a little observing with a telescope. Okay. So one of the main parts of the book I tackle is gravitation. And here's basically how I did it. I relied on three people to tell stories of them and then relate it. First, of course, is Isaac Newton, because, of course, Newton's law of universal gravitation still is used to guide spacecraft throughout the solar system, land astronauts on the moon, and so on. It's still incredibly successful. And because Newton was born just days after Galileo died, I would assert that Newton picked up the baton and ran with it. So we really had to deal with Newton because it provided the explanation of the mechanism for certainly the Copernican system and more. And then we couldn't avoid this guy. We could not avoid Einstein if we wanted to be contemporary. So the book does segue over into Einstein's theory of relativity and general relativity. There's only two equations in the book. One is F equals ma and the other is E equals mc squared. So I had to be a little careful and deft at doing this. I hope I succeeded because we do deal with the ramifications of Einstein's ideas in relativity. And I sort of joke in the book that maybe he's already met the two of them. And if he has, maybe they can solve the problem of dark matter. And if they do, they should let me know. They're dead. They don't get the Nobel Prize money, but maybe it won't do them any good anyways. But maybe I could get the Nobel Prize money. But I haven't heard back from them, so they're still working on it. And finally, I definitely needed to rely on this man, this Subramanian Chandrasekhar, actually a professor of mine. This is when he was much younger, but in the 70s, I took his course on black holes. And so talking about collapsed stars, white dwarfs, black holes, you really want to bring Chandra in on the story as well. So in the book, I go with the support and help of these people work on gravity and its implications. There's a lot of sections, not just on the basics, but also on actually black holes and dark matter, of course, which is one of the outstanding questions of the day. So that was the gravity side. I had a lot of ground to cover there. I had literally a lot of ground to cover because I couldn't assume that Galileo knew how the universe is put together. Remember, he just getting out of this thing over here over to a Copernican sort of model with the sun and the earth going around the sun and the moon going around the earth. This is state of the art, 1610, all right? And the stars, he wasn't even clear what the stars exactly were. So I had to bring him up to speed and always have a model before him. I know Bill teaches and other people teach, having people have a good scientific model is important. So I had to make sure Galileo had the right model in his head too, as I started to explain things, only the scope is far larger than what he was used to. One of the things I used was the following. So of course, he did not get to see Saturn in situ like the Cassini mission did, of course. But I used these devices, the illustrations. There's a lot of illustrations in the book. I'm sure you've all seen the Powers of 10 by Charles and Ray Eames. But I always feel 10,000 is a more important number. My wife thinks I'm nuts. I'm always talking to her about 10,000, but I think it's a really great number because the universe seems to change on scales of 10,000 easily. And Galileo would get this hands down. He's a mathematician, so I don't worry too much about him. And so, for example, the distance between Florence and Pisa, if you multiply it by 10,000, you come up about the distance of the moon. So right there's one major astronomical scale. You go 10,000 times the distance to the moon, you get out to Neptune. Okay, so I have these illustrations where I try to take these, I call them hops of 10,000. So we did those 2 hops. I've got more hops because this was just the solar system. To get to the stars, to get out to Sirius, take the diameter of Neptune's orbit and go 10,000 or actually 20,000 times Neptune's orbit, and you're out to Sirius, a bright star. Galileo obviously knew. He had no way to measure these. He knew how you could, if you're a Copernican, you knew that the parallax with the Earth seeing the stars from different times of the year could allow them to measure, but they didn't have accurate enough telescopes to do it back then. And then to go even farther, we live in a galaxy of, almost 100 billion or more stars. And to get that from Sirius, you go another 10,000 times to get out to that. So building these scale differences, helping Galileo understand this. I did it with illustrations and discussion of these things. So if he's going to be brought up to speed, he needs to know what realm we're dealing with. So that thread runs through the book as well. The third thing I had to talk to him about, to at least have the underpinnings, we need to get him up to speed with at least what a high school student might know in one of Bill's classes, and even beyond a little bit. And then finally, dark matter is such an outstanding question. Currently, I figured he really wanted to know about it. So I had to be able to get him to understand the regular matter and then even dark matter. And of course, everyone in astrophysics knows that in the 19th century, the invention of the astronomical spectroscope is when the word astrophysics was actually coined. It was using spectroscopy on the heavens. George Ellery Hale, I believe, at the University of Chicago, coined that. Astrophysical Journal is our main journal. Galileo would have seen, I'm sure he would have seen spectrums and prisms. I'm not sure exactly what he thought about. I don't know that much about his history. He certainly didn't have ones that would show these dark lines on the spectrum. These are, of course, we now know them as the Fraunhofer lines. They're not hard to even see with a reasonable spectroscope for regular people today. But those spectrum lines, which represent the notes, if you will, of atoms absorb and sing their tunes, allow us to chemically analyze the universe and also physically analyze the universe. Almost everything that Bill and I learned in graduate school and doing research relied on doing spectroscopy. Without the spectroscope and the telescope, we would know almost nothing. Add to this, Galileo probably, I would had to work to help him understand infrared light, radio light, X-ray light, because these are important for decoding a lot of things too. So the book goes a bit into helping him understand the constituents of atoms and molecules. So for example, the water molecule of hydrogen and oxygen, I have to explain that. This is typical of some of the illustrations I do in the book. I take the pictures I take from my telescope. My wife said to me, says, those black round things dress them up a little bit. So I sort of drew on them as if they were on a blackboard. And of course, this is the Dumbbell Nebula that has, M27 has green for ionized, doubly ionized oxygen and red for hydrogen. So we're actually seeing directly in the light of the molecules that go into water. And of course, I had to explain invisible light. So radio waves come in, and I didn't even say here too. He wouldn't even know what a photograph was. So there's a little bit of imaging in the book as well. Not a lot, but just a little bit. And I had to explain radio waves because he would definitely need to know about this guy. This is the light with the shadow cast by M87, the black hole at the center of the galaxy, Messier 87, done by the Event Horizon Telescope, where they've taken, like, I think 8 millimeter wave telescopes around the planet and combined the images. So you've all seen these things in the news. Galileo needs to know about this. If he's going to be brought up to speed, he needs to know M87 and the black hole that's there. Okay, so those were the three basic concepts I worked through. Of course, I give many more examples of the things we learned from them, but those were the building block areas I had to do, namely matter, the models of the universe, and also gravitation. Once I had that, I'm pretty much good to go as the book proceeds. The other thing critical to know about Galileo was he was a tech head. He wasn't just some idle theoretical. I mean, it's amazing how much he did or could do. He invented, these are objects of his at the Galileo Museum. The one on the left is his military compass, which was actually a calculating device that he sold to interested parties, okay, and made money on it, and also he actually had a graduate student who would train people who bought the military compass. He needed the money. And the one on the object on the right is called a Jovilab, and it's a device used to predict the timings of the moons of Jupiter. It's like these are the pocket or the cell phone apps of the day that would be used. So he was a tech head, and the telescope is, the astronomical one, at least, he's famous for. And so the book, he's going to want to know about modern telescopes and what's going on. Of course, here's two of his telescopes in the Museo Galileo. These tubes, I don't know if you've ever used one. They're really challenging because the field of view is so tiny. It's amazing he did what he did. But I had to go from his understanding of a telescope. I definitely had to explain this guy. This is the 100-inch telescope that Edwin Hubble used to basically set forth the extragalactic universe, spiral galaxies, and also the expanding universe with this behemoth. It's much, much bigger. And also had to explain this type of, if you want to, I don't know, call it a telescope. This is a gravitational wave detector. This is the one located near Pisa. So right in his backyard, there's a device to do what we now call multi-messenger astronomy, listening to colliding black holes, colliding neutron stars, and other phenomena like that. So the last time I was at the Museo Galileo, Giorgio Strano, who's the head curator there, he gave me a lesson in using a Galilean telescope. But there's a lot, sometime if we're ever together, Bill, or something, I can tell you more about it, but they are quite challenging, and there's some curious optics going on with these things. So they're maybe not the best example of ways to look at the sky, and I'm just awed that Galileo did all that he did with these simple devices. So part of the book, I decided I'm going to take him stargazing. So I do bring him up to speed with my telescope. Here's my eevee scope to show you my situation. There it is in its backpack. It weighs 20 pounds, so I can put it on my back and go just about anywhere. Here I am setting up. I have in the lower right is my house. It's in Oak Park. There aren't a lot of oaks here anymore, a lot of elm trees, a lot of maple trees. It is pretty heavily forested. So any observing I've done here, I did from the back platform where we park cars and also near the alley. And I know exactly where my sky windows between the trees are. And with apps and help, I'm able to find out where objects are and go after them. So it was really interesting. Also, I have a lot of overhead wires. And I found I just shoot through the wires. I do relatively well. So given all this telescope is about the size of Galileo's. It's just a lot easier to use. And again, here's a picture of it put up. It's very similar to the Stellina. It has a 4.5-inch mirror. I think it's a Newtonian telescope. Actually has an eyepiece with a little monitor in it. It's kind of fun, but basically you look at the images, you can look at them through your mobile phone. The other beauty of it is that it stacks them. It takes 4-second exposures repeatedly and averages them when you go into a certain mode. So you're able to get down. I can get to 16th magnitude here in Oak Park. I've seen Pluto without too much troubles. Quasar too. And the actual looking through this thing or watching this, it's equivalent in many ways to a 1 meter Dobsonian in terms of light gathering, only the eevee scope sips the photons rather than gulping them. It's a lot easier to use, extremely powerful. At the end, I'll show you my Messier objects. They also do, I won't say a lot about it, but this scope is connected also with the SETI Institute. And we have actually tonight, I missed it because the weather's bad. It was bad last night too. We go out and we look at exoplanet transits. And there's hundreds of people that do that at once with these things, and then they get analyzed at the SETI Institute. So there's a lot to do here. So I took him essentially stargazing. I'm going to show you a few things that actually appear in the book in one form or the other that I've gotten with these eevee scope, these examples. M13, the famous globular cluster in Hercules. This is a 3-minute stacking. Looks pretty good. Here's the Eagle Nebula, pillars of creation are in there. This telescope has about a 1/2 degree field of view. If you can picture that, it's on its sensor. It's about 1 million pixels in one of these images, and it images in color, which is really quite nice. This particular one, I actually put a filter on to pull out the hydrogen light especially. But this is done in Oak Park. Actually, this one was on a really crummy night, and the nebula was pretty low near the horizon. I actually got it. So that's another one I showed him. Here's M104, right? The sombrero. Not too bad for 8 minutes. And of course, M51, really poster child of spiral galaxies taken here as well. So there's a bunch of these in the book. So I have my own pictures. I rely not so much on the Hubble pictures, a couple times, but let's go with those. And the last one I got here, this actually didn't find its way into the book. There's another one. This is the Perseus cluster of galaxies. There's, when you're looking at this, is approximately 1,000 galaxies, 240 million light years away. So it's pretty mind-boggling. And if I'm going to show him things like this in the book, I think I show him coma. I have to explain these to him. So it's really quite a challenge. And one of the other big stories is, of course, things like the Orion Nebula and the cycle of stellar nuclear processing and in formation of stars and so on. So the idea that now these elements form in stars, but also form us as well. This is a star nursery. So, and this is typical of some of the illustrations where I illustrate on top of these things. So if I just also wanted to share with him a little of the wonder I get and that I've shared with people just doing stargazing with this amazing telescope. And in the end of the book is an exercise in living through this period as well. And one of the big points of the book I try to make is that through doing astronomy in particular, thinking about science, we can actually escape our confinement, so to speak. And one part of it is realizing that science has always, science is always filled with questions, right? And that it was no different in Galileo's day than it is today, that we just don't know about a lot of things. And it's fun to look at his descriptions of trying to explain what he's seeing on the moon. He didn't know. He had some wrong answers. He had some good answers. Similarly, on the right here, his observations of the satellites of Jupiter. He really, at first, he did not know what he was looking at. And then it turns out that actually trying to reckon these into orbits and some sort of patterns is really much harder than it seems. And so he would really appreciate that we had unanswered questions today. And I think that's a big part of the what helps with the wonder. And there's an example from the book. I spend a couple chapters talking about dark matter, and in one, I do a thought experiment, okay, where I imagine if we drop a dark matter ball, if we could, I don't know, don't ask how we make this. This is a thought experiment. But if we had one and we dropped it from the Leaning Tower of Pisa, what would it do? Any answers? Bill, do you know what it would do?
It would go through the earth and then yo-yo back.
Yes, exactly. So it takes about a half hour, I think is about the period. It would just go out and come back. So in the book, we use this as a thought experiment to connect back with his story. Anyway, so that there are questions today unanswered that are just as important in their own way as understanding the features of the moon or how the solar system works. To me, it's liberating. It connects me back with him. These wondering questions, in the end, is what really makes science great. And he was a big part of that. Even though he was confined, I was confined, we can be taken out of our world through that. You know, when you look at the starry sky, of course, another very famous Tuscan put it into great words. I don't know how your Italian is. E quindi uscimo a rivedere le stelle. All of the Divine Comedy always ends with, and then they went out to see the stars again. And so I definitely felt, I'm sure Galileo would be sympathetic with this, that stargazing is probably one of the best things you can do in this sort of time. Anyways, grazie mille. If you're interested to learn more about this, you can find my book. It's on Amazon as a Kindle. Currently, we're just finishing. There's a paperback edition being put together. The designer just finishing it today. So, anyways, that's the book. Let me show you one other thing, and then I'm happy to take a lot of questions. I want to show you, because I'm so proud. I was working on this today too. I don't know if you can you see my screen now?
Yes.
Okay, so this is, I'm not done with it. I'm just starting with it. This is, I'm putting the 110 Messier objects on a poster, making a poster. I had a friend ask for a poster. So these are the ones that I've seen. I don't know if I can make these bigger here. Yeah, I can a little bit. You can see some of the quality of these nebulae. And I've also arranged these from closest to us to farthest. So there's a certain type of cluster at the bottom, and here's M31 and other galaxies as we go to the top. So I'm kind of proud of this. I still have to put all these in carefully, but this is another thing I've done with this. Anyways, so maybe I'll stop screen sharing and take it wherever you like, Bill.
Well, that was great. I'm looking forward to the paperback because I don't do Kindle yet.
You can get, I should say you can get, if no one's done this, you can get the Kindle app. It's free. It goes on your desktop, your laptop, your iPad, or your phone. And actually the app is really good because it's in color. The regular Kindle's not in color. There's over 80 illustrations. So anyways, we'll get you a hard copy anyways.
But I also want to underscore what it was like to look through his telescope, the Galilean telescope, which was not an inverting telescope, but its field of view was so tiny.
Yes.
I got to look through a replica in Boston, and it was so hard to figure out what I was looking at. And so when he did the moon, he had to basically put together a mosaic in his mind.
Mm-hmm.
And then when he did the Pleiades, he had to do the same thing. He had to keep track of all these positions of the stars because it was not available to him as an image.
Right. I remember the field of view is really small. he was a good artist. You know, he's trained in art, so but a lot of effort. I was just curious how they were mounted. And when I saw Strano a few years ago in Florence, he pulled out what they think were the sort of tripods. It may have been a tripod Galileo used. So it's just a very simple tripod. But it's heroic.
Yeah.
What it did with those. Absolutely. And the other thing is as you move, I think the image is actually formed on your retina. It's not like a Keplerian telescope. You're examining the image which is formed inside the telescope. The Galilean telescope, the image is formed on your retina. Okay. And so as you move your eye, you feel the view gets bigger too. So that's another way to deal with that, Bill, is that you get used to moving around. It's crazy. I'm much too lazy to have done that.
Are there any other questions for James? Yeah, Paul, unmute yourself.
Yeah,
Okay, Paul. We still can't hear you. You might be frozen.
gravity and things like that now that we have large computing.
Hold on, Paul. Start again.
Okay, James, we have the advent of AI, and do you think that as large computing power becomes more accessible, it will help us find out more about things like gravity and some of the other scientific mysteries that we have?
Yes, Paul, I'm not sure. I mean, I don't do programming in that or research that, but I know that AI and big science and data science is huge in the astrophysical community now. And in fact, my alma mater, the University of Chicago, just started a large data science center. And because we get so much data from these observatories and telescopes, and we have a lot of legacy data as well. And that I know that if you or I were going to be a graduate student now, we would be data scientists first, and probably never get close to a telescope. I mean, the Rubin telescope alone, no one will ever be there except for the engineers who keep the lights on and keep the computers taking data. So an AI will, being able to program to do things effectively and efficiently is going to be really important.
I know it's used for classifying things.
Right.
Like galaxies.
Certainly.
Yeah, I had one other question too.
Yeah.
There's a huge amount of these little satellites, low orbiting satellites going up, bookcase type things. If they put up, they're talking about like 5,000 satellites. Is that going to hurt astronomy, or are they whizzing by at a low Earth orbit that it's not going to make any difference?
It's a really good question. You asked the right persons. I'm on the American Astronomical Society's committee that's dealing with it. We just put out a report called SATCON 2, and we are extremely concerned. And that's because, and when they're low, they're brighter. Okay, and it's not just 5,000. We're looking at, by the end of the decade, 40,000. So if you do the numbers on that, that's about how many, in there have been experiments with SpaceX to get the Starlink satellites fainter than 7th magnitude. That's what they'd like. If you do, I think there's, Bill probably knows, there's about 40,000 7th magnitude stars in the sky. So when there's 40,000 things going, if you took your binoculars up, any of the 7th magnitude stars, half of them would be moving. So it's a huge issue. This is principally around dawn and dusk for the lowest satellites, because that's when the sun's light hits. But a 7th magnitude, even an 8th or 9th magnitude star is a disaster for something like the Rubin telescope. My little telescope, last 3 times I've been out at dusk, as the weather has changed, or just this autumn came, 2 out of 3 times I've gotten photobombed by a Starlink satellite. There's an app for your phone called GoSatWatch. I recommend you get it sometime and just take a look. You'll see how many are in the sky. There's already thousands. And the thing is, it's kind of out of control because there are many companies. It's not just SpaceX. It's also Amazon and who knows, there's all kinds of other companies. So there could be tens of thousands of these things. And they won't be visible in the boost phase. They're visible. You could see them as they're going to orbit. Once they get on orbit, if you take binoculars out, you would see them easily. If you do astrophotography, you'll get photobombed at certain times, especially. So they are a serious issue. They are also an issue for radio frequency interference. I don't know tons about that. And also the other thing you just saw this week, something related to the Russians destroyed a satellite, right? It causes, and got 3,000 debris. Those debris are going at 17,000 miles per hour. And so the issue of satellite debris and an effect called the Kessler effect is if these things start banging into each other. There's, I live in a big city. The Dan Ryan Expressway is a hell of a place to be, but it's going to get like that in low Earth orbit. So it's a huge issue. It's not clear who regulates it. There's efforts, pressure being applied to the FCC to try to regulate this. It's a mess, basically. Read this. If you go to Google SatCon or SatCon 2, there's reports on this.
Thank you. That was a good representation of the current status of these pests, astronomical pests. We have a question from Eleanor Harris about the orbits that Galileo imagined. Did he imagine these orbits of the moons around Jupiter and of the planets around the sun as being circular?
That's a good question. Thanks for asking, because I was just talking to my wife about that. She's actually a little more read up on him literally than I am. I think he thought they were circular. But of course, he lived the time of Kepler.
Right.
So Kepler was a colleague and a contemporary. I think he thought Kepler was a little odd, but he certainly would have known Kepler's laws, and Kepler posited elliptical orbits. So I'm not sure myself, but I think he paid attention to Kepler, knew Kepler was a good mathematician. He thought he was a little odd. I don't know why.
So I have another question. So you've written this book explaining a lot of things to get Galileo up to speed. How do you think he would receive this book?
I haven't heard back from him. If you read the book, you'll see that I get quite frustrated that he doesn't respond. But there's the preface has a letter he's writing to Viviani, his disciple, trying to explain to him that he's gotten these strange letters. So the book does go through this a little bit. Remember, my wife is a fiction writer, and so a little bit of trying to understand, am I a nutcase? There certainly were plenty of nutcases around then. So who knows? That's a really good question. I left out a lot of things. I didn't even broach the subject of astrobiology with him. That may be a future book. I don't know. We don't have any discoveries yet, but it's a good question. I don't know. It's as he says to Viviani, he doesn't want this knowledge to get out too much because he's already in enough trouble with the church. And if they think he's talking to some spirit from the future, that's it for him.
Hmm. Well, any other questions? Michael, do you have any thoughts? Unmute.
No, not at the top of my mind, no.
Okay.
Very nice talk.
All right.
Thanks.
So James, as I said, we look forward to both the Kindle and the paperback versions of your book. I think it was a neat premise starting out, and I'm sure it goes great, considering that you are a wizened storyteller as it is.
Right. Well, thank you very much. And by the way, if you do talk to him or hear from him, tell him I'm waiting to get some response. I've got no response from him.
He might only use text.
Who knows? Anyways,
Okay.
good luck. Thank you so much.
Thank you. It was great. Take care now.